Hello everyone. So we had finished the first chapter, some basic concepts of chemistry. Hope you understood that. We had done a lot of numericals and you hope you had done with this thing. I hope you have understood the basic concepts. Now we are going to move to the next chapter, that is atomic structure or structure of atom. Atomic structure, or we call it structure of atom. Now, if I ask you the atomic structure, you have a concept. Now we will see after this particular chapter is finished, your concept will be completely changed. Okay. So what we know is just a little bit fake thing, kind of. The very basic things. Okay. So, but obviously I cannot move to that particular thing which you are going to know at the end of the chapter directly. Okay, so I'm going to move slowly. I'm going to recap the thing. Today actually I'm going to tell you some story of the atomic structure which you already know. It's nothing new we are going to talk about. That is recapping of this, then slowly we will move ahead. Okay, so first atomic structure, when it was known that something called atom is there, it was told by Dalton. You must understand this. It was told by Dalton that the atoms are indivisible. They cannot be indivisible. They cannot be divided. They are the smallest one. But with the discovery of electrons, by J.J. Thomson, right? Who discovered electron? It's J.J. Thomson. Okay, in his which experiment? In his cathode ray experiment. Okay, the concept of indivisibility of atom, that is Dalton's theory, had gone completely. That means at that point it was found that yes, the electrons are there present in the atom, and we can get that electron, means atom can be divided. Okay, can be broken down. Okay, then the students of Thomson, they had just modified this cathode ray chamber. We call it, that particular instrument where lead it is called cathode ray chamber. Modified that cathode ray chamber a little bit, and they performed another experiment which is called canal ray experiment. And by those experiments, they discovered actually, by that particular experiment, the modification form of the cathode ray chamber, they could discover another particle, another subatomic particle, which is proton. Okay, and we know that electron, they found that the electrons are negatively charged particle, the protons are positively charged particle, and hence the atoms are remaining as neutral. Okay, fine. Then the scientists started thinking, okay, initially we thought that's the indivisible particle, so that's a single particle. But now we have to explain the structure of the atom. Now there were so many scientists has given so many models of an atom. Okay, but the first one which was accepted actually, but not for very long, accepted was Thomson's, again J.J. Thomson's resin pudding model. We call it resin pudding model, or this is also called watermelon model. The resin pudding model or watermelon model. But when he proposed this particular model, how many subatomic particles were there? Only 2 subatomic particles were discovered, electrons and protons. He told that the atom actually is made up of protons. For example, suppose if you are thinking of a pudding or a watermelon, the whole of watermelon is made up of positive charge. That is protons. This is proton. These are all proton. Okay, proton. That was his concept. And some electrons are embedded in it. Just the resin that is present in the pudding, or the seeds of the watermelon that is present in the watermelon. Okay, they are embedded in it. That was the concept of Thomson about the atom. But obviously this particular model of an atom could not explain much. That could not explain much at all. Okay. of the properties. So this particular concept was not very well accepted. In the meantime, what happened? In the meantime, one scientist called Rutherford, you have heard about it? Yes, heard about him? I hope so. Okay, Rutherford, John Rutherford. Okay, what he did a very interesting experiment. He did an experiment called alpha ray scattering on gold foil. Okay, he did an experiment like this. Okay, I'm just trying to say this, but kind of, obviously in brief one. I cannot say the engineering detail of the experiment, but you can understand that. Alpha ray scattering on gold foil. So he had chosen alpha rays for this. First, what are alpha rays? These are positively charged particles. Actually, these are nothing but helium nucleus. So let us know at this moment that they are positively charged particles. So here was a source of alpha ray. From where the alpha rays are bombarded. Fine. Okay. First thing, alpha ray. Then that is scattering on the gold foil. Now the question is that why did he take gold foil? Why not other? He took gold foil because it's highly malleable. It can be converted into very, very thin sheet. Okay, that is why he took the gold foil. Okay, that is the reason. It is highly malleable. Okay, that is why he took gold foil. Fine. He bombarded these alpha rays in a gold foil. Suppose this is one atom of gold. Just suppose this is one atom of gold. He bombarded this alpha rays. He observed mainly three things. First, most of the alpha rays are just going through. Most of the alpha rays are just passing through it. That's the first point. Okay, most of them are passing through. That's the first thing he observed. Second thing he observed is that around, on an average, 1 out of 20,000. If 20,000 alpha particles are bombarded, one of them is hitting something in the atom and coming back. Hitting something and coming back means it's rewinded back. That's the second important observation he had observed. 1 out of 20,000 alpha particle comes back or rewinds back. Okay, rewinds back. Fine. That's the second observation he observed. Second important observation, I should say. And the third observation he observed is that some alpha rays are just deviating away. It's not going through straight. While going, it is just deviating away. It's undergoing the outswing. Okay, it's deviating away. Very few are deviating away. Now, why these three observations, main observations he observed? Then he concluded from these three observations, he concluded 3 points about an atom. It's very simple. Please understand, it is very simple. The first observation, that where most of the alpha particles are passing through, from there he concluded that most place in an atom is vacant. Most place in an atom is vacant. Nothing is there. That is why it is passing through. Clear? The second observation he saw is that 1 out of 20,000 particle is hitting the gold foil and coming back. That means there is something in the center of the atom which is very solid. Something at the center of the atom which is very solid and positively charged. That is why it is going, hitting and coming back, repelled back. Because alpha particle is also positively charged. So it is going, hitting and coming back means what? The one that is present at the center is also positively charged. That's the second point he concluded. That at at center a hard positive charge is present. Positive charge is present, and he named it as nucleus. He named it as nucleus where the protons are present. Protons are present. Okay? Fine. And from the third observation, what did you observe third? That it was going and then certainly deviating away. It was going and certainly deviating away. Why that is deviating away? The positive charge is going. It is without going through, it is just deviating away. Means towards that side some negative charge is there. Towards this side some negative charge is there. And he concluded to the fact that the electrons, negative charge means what? The electron that is present in atom. The electrons are moving surrounding the nucleus. Okay? These are the three conclusions he made by his experiment, and he proposed the structure of an atom. Okay? He proposed that the atom, there is at the center there is a nucleus, and this nucleus contains the proton, and the electrons are moving away where he didn't tell. He didn't say, he couldn't say where. He just told the electrons are moving away, moving surrounding the nucleus, in some circular paths, okay, in some circular paths. But that much he told. But in the meantime, when Rutherford was performing this experiment, one scientist called Sedgwick, or we also call it Chadwick, okay, he discovered another subatomic particle in the atom, and which is nothing but neutrons, which are neutral in this. Okay, then where are the neutrons present? Then Rutherford told, okay, neutrons are also present. These are all model, and coming from little bit of experiment, the neutrons are also present at the center, okay, in the nucleus. This was Rutherford's model. It was accepted for few days, okay, few years, okay. Then some problem had been arose with this, that it could not explain certain facts, okay, and those are the limitation of the Rutherford's model. The most important fact it could not explain is this one. You see, he told, okay, fine, the electrons are moving, the negatively charged particles are moving surrounding the nucleus, fine, where he didn't mention. But we know that if a charged particle like electron moves in a circular motion, it will lose the energy. And if it loses the energy, this is nucleus over here, okay, it is losing the energy. If it loses the energy, it cannot move like this. It will slowly, it will slowly spiral into the nucleus. It will come spiral into the nucleus. And if it spirals into the nucleus, there is no existence of the atom. And hence, this particular model of an atom was not accepted for long. Is it clear? In the meantime, let me tell you one more thing. In the meantime, one more scientist called Millikan, okay, he did an experiment called oil drop experiment. I'm just going, obviously we are not going to know the detail of these experiments, just know the names, just the history. Oil drop experiment, where he found the charge to mass ratio of the electron, and finally he found the charge separately and the mass separately of the electron, and we must know this, okay. The charge of the electron was found to be 1.6 into 10 to the power minus 19 coulomb, and the mass is found to be 9.1 into 10 to the power minus 31 kg. These are the charge and mass of the electron that was found by an experiment done by or performed by Millikan, and the experiment is known as oil drop experiment, and from there we got it. Yes? Okay. So this is, so till Rutherford's model we know, But you know Rutherford's model when was discarded, then came Niels Bohr, which you know little bit you know. Okay, I am once again saying little bit. Okay, Niels Bohr came and Niels Bohr proposed such certain model with certain experiments. So we will see that next day. But before that, we must know certain more terms also. Okay, some more terms also, so that it will be easier for us to study the structure of an atom. Hope you understood, or hope you understood little brushed way of this history, which you would have known also earlier, but now you know it maybe in a little brushed way. Okay, so what was this thing? What was certain terms which you must know. Okay, and you should know it also. You know it, I know you know it also, but again I'm just recapping it. Now first one is atomic number. So one thing is very clear up to here, whatever I told, that an atom is not indivisible. It is broken down into three subatomic particles, the protons, the electrons and the neutron. Out of that, the proton is positively charged, the electron is negatively charged, and the neutron does not have any charge. That's a neutral element. Now what is atomic number? Atomic number, that is denoted by, that is denoted by Z. That is denoted by Z. The atomic number is denoted by Z. And atomic number is nothing but the number. Be very careful. Don't get confused with atomic mass. Atomic mass means mass of an atom. That's a completely different concept. And atomic number means some number. Number of proton in the nucleus. That is atomic number. Okay, atomic number. Then next is mass number. Please don't get confused with the mass. This is mass number, a number which is denoted by A, which is nothing but the number of protons plus number of neutrons present in the nucleus. Number of protons plus number of neutrons. Okay, so if I ask you what is the number of neutron, number of neutron is nothing but A minus Z. And for a neutral for a neutral atom, we know that number of protons equal to number of electrons. So for a neutral atom, the number of proton, whatever is the number of proton, that is atomic number, is the number of electrons also. That is atomic number, mass number, two terms. Then the next term is isotopes. You had heard about this, I am just recapping it. Isotopes. What are isotopes? These are elements, different atoms of the same element, okay, having the same atomic number but different mass number. For example, suppose carbon has got two isotopes. Carbon has atomic number 6, and the atomic number are generally written at the left hand side bottom. Okay, left hand side bottom. So carbon has atomic number 6. Okay, having the same atomic number but different mass numbers, the atoms of the same element are called the isotopes. One of them has got mass number 12. Mass number is written as left top, and the other atom will have the mass number 14. We had seen that isotopes were studied in the previous chapter also. So this is isotopes. Okay. The next one is isobars. What is isobars? They are different atoms having the different elements, having the different atomic number but same mass number. Having the different atomic number but having the same mass number. Whenever the atomic numbers are different, there must be atoms of different element. For example, suppose if I write this, carbon 14-6 is there, carbon 14-6 and nitrogen 14-7. You see, both are different atoms, different elements. What is there? 7 is the atomic number of 8, 6 is the atomic number of 8, but the mass number of both of them are same. These elements or these atoms are called isobars. Okay, these are called isobars. And the last term we are going to know today is isotones. 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 What are isotones? They are also of different element, different atoms. Okay? Neither their mass number is same nor their atomic number is same. Atomic number same होने का कोई chance ही नहीं है because they are of different elements. Okay? Their atomic numbers are certainly different and their mass numbers are also different. But what is same is the number of neutrons. What is same is the number of neutrons. Okay? For example, suppose this one nitrogen. Okay, whatever. Okay, magnesium 2412. Magnesium 2412. Okay, and sodium 2311. Sodium 2311. Okay, you see both are different elements, different atoms. Clear? The atomic numbers are different, the mass numbers are different, but what is the number of neutrons over here? A minus Z, that is equal to 24 minus 12, that is equal to 12. What is the A minus Z over here? 23 minus 11, that is also equal to 12. So the number of neutrons are same. Number of neutrons are same. Then those elements are called what? Those elements are called isotones. That is, these are the terms we must know, so that now the history you can say of the wrong concept of atomic structure, but obviously from the history only it generates, the theory generates, theory uplifts. Okay, we will come now to the next part of it next day, that is the Bohr's theory. Okay, till then, goodbye. Thank you. Stay safe, stay healthy.